Have you ever looked at one of those massive container ships and just wondered, how on earth do you steer something that big? I mean, it's like a skyscraper floating on water. Well, today we're going to dive deep into the incredible engineering that makes it all possible.
Seriously, just look at this thing. We're not talking about your average boat here. This is basically a floating city block. When you've got hundreds of thousands of tons of steel moving through the water, a simple steering wheel just isn't going to cut it. So what's the secret? How do they pull it off?
All right, let's get right into it. Before you can even think about steering, you got to get moving, right? You need pure, raw power. And for these absolute giants of the sea, it all starts with the propellers. This is the engine room of the whole operation.
So, what is a propeller? Well, the easiest way to think about it is like a huge, incredibly powerful fan. But instead of pushing air, it's designed to bite into the water, grabbing it and throwing it backwards. That motion converts the engine's power into forward thrust, pushing the entire ship through the sea.
Now, not all propellers are created equal. You've basically got two main types. On one hand, you have the fixed-pitch propeller. It's the workhorse, simple, super durable, and cost-effective. But then you've got the more advanced controllable pitch propeller. Its blades can actually change their angle, or pitch. This makes it way more efficient at different speeds, kind of like having gears on a car.
And check this out, here's another key design difference. On the left, you see a standard propeller, just out in the open. But on the right, that's a ducted propeller, sometimes called a quart nozzle. See that ring around it? That's not just there for protection. It actually funnels water directly into the blades, which can seriously boost the propeller's power and efficiency.
Okay, so the propeller is pushing us forward. We've got momentum. But how do we actually tell this colossal vessel where to go? All that forward power is totally useless if you can't steer.
And that, my friends, is where the rudder comes in. It's that huge fin you see at the very back of the ship. It works a lot like a fish's tail, actually. As water flows past, turning the rudder creates a pressure difference, high pressure on one side, low on the other. That difference literally pushes the back of the ship, the stern, to one side, causing the whole vessel to turn. It's basic physics, just on an absolutely massive scale.
And this is where the engineering gets really clever. It's not just one design. As you can see in this chart, it all comes down to where the rudder's surface is relative to its pivot point. A balanced rudder has a good chunk of its area in front of the axis, which means it takes way less force to turn. For a giant ship, that's a game changer. An unbalanced one is simpler, but you need a much more powerful system to move it.
So there's a catch with rudders. They only really work when the ship is moving forward and has a good flow of water going past them. So what do you do when you need to make super slow, precise movements? You know, like docking a massive cruise ship in a tight, crowded harbor.
This is where thrusters come into play. They're basically small propellers, or jets, that are built directly into the hull of the ship and they point sideways. You'll usually find one up at the front, the bow, and another at the back, or stern.
And this is their secret weapon. The captain can fire up the bow thruster to push the front of the ship to the side, or use the stern thruster to nudge the back. And by using them together, they can do something amazing. They can move the entire ship perfectly sideways, or even pivot in place without moving forward an inch. It's all about that fine-tuned precision control you just can't get with a rudder alone.
So let's put all these pieces together. It's not about just one of these systems, it's about how all three of them work together, in concert. You can really think of it as a perfectly coordinated symphony of movement.
So, to stick with our symphony idea, the propellers are the huge percussion section, just laying down that powerful driving beat that gets everything moving. The rudder, that's the conductor, guiding the whole orchestra and setting the main direction. And the thrusters, they're like the woodwinds, adding all those delicate, precise notes you need for the really intricate parts of the performance. Power, direction, and precision, all working as one.
But what if you could combine parts of that orchestra? Well, that's exactly what the azimuth thruster does. The entire unit, the propeller and everything, can spin a full 360 degrees. This means you can point the thrust in literally any direction. It's both the engine and the rudder all wrapped into one incredible package. You see these on tugboats and ferries, and it's what makes them so unbelievably agile. Pretty cool, right? And that really brings us to a fascinating final thought. We're already seeing technology like the azimuth thruster merge power and steering into one. So it makes you wonder, is the classic setup of a separate propeller and rudder on its way out? Could we be heading towards a future where all ships are controlled by a single elegant system? That's a really interesting question to think about for the future of shipping.